Welcome and thank you so much for joining me today. So we are going to be rationalizing denominators, and all that means is that we don't want to see square roots on the bottom. We try to avoid that as much as possible, so we try and think about how we can get the square roots away from the bottom. Now to do that, I just want you to think about what's the opposite of a square root. Squaring. So if we're squaring it, we are cancelling it out. So to think about it that way, if we've got if I say I've got square root of 4, I know if the square root of 4 is going to equal 2. So if I want to have the 4 without the square root, just get the square root away, I times it by itself. So if I times 2 by 2, I'm going to get to 4. So that means if I go square root of 4 times the square root of 4, the only thing that's going to happen is I'm going to be getting 4. The square root will cancel out. Because the square root of 4 is 2, the square root of 4 is 2, 2 times 2 equals 4. So I wanted to show you in an easy example where you're able to see how that works. So now let's apply that understanding. I don't want the square root of 6 there, so I want the square root gone. So to do that, I times it by the square root of 6. If I times the bottom by the square root of 6, I can times the top by the square root of 6. Now I could have just said square root of 6 divided by square root of 6 will be 1, which is right. Because these cancel out, and it just becomes 6 over 6, which equals 1. Let's have a go with this question here. So we have at the moment 3 times square root of 2 divided by square root of 5. I need to get rid of the square root on the bottom, so I times it by itself. And that will cancel the square root out, which means I times the top by square root 5. So I can rewrite that as 3. Remember the rule? 2 square roots can be times together. 2 times 5 equals 10. Square root of 10 over 5. And there we have it. I could simplify this, but and have 2 surds, but there's no point because I can't get rid of the surd from there. Let's have a go at this question here. Now, what we've got here is we've got 2 square root 6 divided by 5 square root 2. Now I just want to get the square root gone. So I don't have to times it by everything, I just need to times it by square root of 2. Whatever I do to the bottom, I must do to the top. And then I can simplify. 2 times the square root. Remember, we've got square root of 6 times square root of 2. That's square root of 6 times 2. Over 5 square root. Now, I don't actually have a square root there now, do I? Because square root of 2 times the square root of 2, it cancels them out, and it becomes 2. So now I can simplify this. 2 times 6 equals 12, so 2 square root of 12 over 2 times 5 equals 10. If I really wanted to, I could think about my squared numbers. 4 is a squared number. So I could change this to be 2 times square root of 4. 4 times what equals 12? 3. Square root of 3 over 10. Square root of 4 is 2, so 2 times 2 is 4. 4 square root of 3 over 10. 2 is a common factor between 4 and 10. 2 goes into 4 2 times. And 2 goes into 5. So 2 goes into 10 5 times. And it becomes 2 square root of 3 divided by 5. I really hope that helps you understand how to do rationalization of denominators.